You are watching the 3.2 video on slope, aka constant rate of change. So in the past, we've called this the average rate of change, but what we want you to recognize is that slope is always constant. So when we're dealing with linear functions, the average rate of change is also known as the slope of a line. So let's fill that in. And this is always constant with a linear function. So we know in the past that we've called slope change in y divided by change in x, or rise over run, or vertical change over horizontal change, or y2 minus y1 divided by x2 minus x1. I prefer to always set it up using a table of values when I need to find it algebraically. But we'll talk about that in just a little bit. So a few things to remember is that slope can either be positive, so pointing up. It could be negative, which is pointing down. It could be zero, where it just goes flat, or undefined, where it's a straight vertical line. Remember, when we read a graph, we read it like a book. So we always go from left of the graph to right of the graph to see what the slope is. Now, we can find slope from equations, tables, graphs, or 2 points. So we're going to take a look at how each of these looks. Now, when we have an equation, it's super easy when it's written in the form y equals mx plus b, which is our slope-intercept form. So y equals mx plus b, because our slope is our m. So our slope in this case is 5. When we want to find the slope from a graph, what we try to find are nice points of intersection where the 4 grid lines meet up. So like that's a really nice point, that one isn't, that one isn't, that one isn't, that one isn't, that one isn't. This one is. These ones are not until I find it here. So when I'm trying to find it on a graph, I'm going to use the rule rise, divided by run. So how can I go from left to right? So remember, we always want to go from left to right. I'm going to go up 1, 2, 3. So up 3 is a positive 3. And then we're going to go to the right 1, 2, 3, 4, 5 spaces. So the slope of this graph is the rise, 3, divided by the run, 5. Now, some people might want to convert this to a decimal. I say leave it as a fraction, because when you leave your slope as a fraction, it's so much easier to graph. So leave it as a fraction. Simplify the fraction if you need to, but leave it as a fraction. Okay, when we're looking at a table of values, we are going to do the same thing. So we're going to be thinking of rise over run, and we want to find the x change and the y change. So let's go through and figure out, how did we get from 9 to 14? Well, if you thought we added 5, you are correct. How did we get from 14 to 19? Well, we added 5 again. How did we get from 19 to 24? We added 5 again. We're going to do the same thing with 7 to 10, 10 to 13, and 13 to 16. We are adding 3 every single time. So if we look at this table, we're noticing that our change in y, so we're going to do y divided by x, so 3 divided by 5. Change in y over change in x. Okay, now our last piece is between 2 points, which we are very used to doing already. We did this already in Unit 2 when we did average rate of change. We are going to set it up exactly the same way. So I'm going to make an x and y table, and I'm going to put the 2 points in, -4, -11, and 1, -8. What we're going to do is find the change in the y. So how did we get from -11 to -8? We added 3. And how did we get from -4 to +1? Well, we added 5. So in summary, we are going to do the same as we've done in the previous 3 examples. We're going to put our y change of 3 divided by our x change of 5.